Great to see you here. This is the last part of the course, and here are the slides that I will present or presented on the weekly webinars. It's the last part, the last lesson, so I'm feeling a little bit sad because we spent a lot of time together. I hope you learned a lot, and this last part about risk management is in fact closing the process steps or the steps, the 10 steps that we had up to planning. So we finished 8 of the 10 steps, and we will continue in the next course, CAPM 2, with the execution and more complex exercises. So we will expand your knowledge there. What is the content of the lesson? We're talking about risk. So we look at threats and opportunities. We look at risk management, the risk management process. We look at risks related to the project. We look deeper into planning risk management, risk identification and the tools, qualitative and quantitative risk identification, PERT and Monte Carlo evaluation and some example about this, risk responses, and of course you have to complete the discussion forum and the end of the lesson quiz. The learning outcomes of this course are basically the ways that you will be able to define risk in a project environment. You will be able to describe the risk management cycle and processes, evaluate risk events, recite the tools and techniques used in risk management processes, interpret the events affecting the project outcome, create a risk management plan, and calculate the impact of risk events on the project. Let's see what risk is about. We see throwing with the dice, walking on the rope, jumping over obstacles, gambling. These are all events that relate to probability. There are some probabilities that we can account to, and in risk management we will be talking about some statistical principles. Of course, when you are a diver, a scuba diver, you are looking at opportunities. You're looking for the shark, and for the shark, lunge is served. So we see the diver has an opportunity to see the shark. For the shark, he may have or she may have a free lunch. And of course, this is also a risk about the diver being damaged or eaten or wounded by the shark. Once somebody asked me, because I was scuba diving, somebody asked me, when you're scuba diving and you see a group of sharks, and he asked me what to do. And I said, well, you just keep on breathing. And everybody was looking at me and said, well, you're never going to be faster than the shark. So the only thing you can do is be quiet, be sure that you don't provoke the shark, and you will see what happens. If the shark decides to attack you, there's not a lot that you can do about it. Now, when we look at statistics, we have to look at some names and some symbols that we are going to use. We talk about distributions and samples, and when we talk about the distribution, we indicate the amount of the items in the distribution with capital N, and when we talk about a sample, we use it as small n. When we look at the mean, we look at the average being mu or m, depending if we have a distribution or a sample. The variance is also very important because it's indicating how far the different elements are spread from each other, what is the spread of the distribution, which is the standard deviation to the square, which is sigma square for a distribution and s square for a sample. The standard deviation is the square of the the square root of the variance, and we see that the standard deviation for a distribution is given by sigma and for a sample by s. Now, when we look at a sample here, we look at those different measures that we can take. So we have here, for example, measurements of speeds of cars on the highway, and we can calculate the mean here, which is the average. We can calculate the median, which is the middle value. We have 50% to the left and 50% to the right. We have the mode. The mode is the part or the number that's occurring the most. We have the range. It's the maximum or the difference between the maximum and the minimum value. We have the standard deviation, and we can calculate the variance. So all these things are characteristic for the measurements that we have done. Now, when somebody tells me there is an average of so much for a distribution or for a sample, that's very nice, but what I also want to know is the variance or the standard deviation. Those two parameters, mean and standard deviation, are in fact very important for our distributions. Let's have a look at some examples here. Here we have a sample where I want to calculate the mean, median, variance, and the standard deviation of the sample. So when I look at the mean and the average, I just add all the numbers and divide it by the total amount of numbers that we had. So for the first one, we find 5.2 when we add those numbers divided by 5, and we do the same for all the others. Now, that's the first thing that we have to find. The median is the middle value. And the middle value, when we look at it, for the first one, we have 5 numbers, which is 5 is really in the middle. So we have 2 to the left and 2 to the right, and 5 is the median. Now, the next one we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So we have 4 to the left and 4 to the right. There is not really a middle value. And in that case, we just take the highest value of the left part and the lowest value of the right part, which is 5 and 7. I take the average of those two. 5 plus 7 is 12, divided by 2 is 6. And we do that for all of them. We can calculate the variance. There are just formulas for the variance that we can use, and we can calculate the standard deviation, which is the square root of the variance. I'm not going to give you the calculation formula for the variance. You should know it from the statistical courses that you had. Now, when we look at the normal or Gauss distribution, which is used in many examples, and the advantage is when we're doing sampling, and we do a lot of samples, we create a sampling distribution, the distribution of samples, and typically this turns always into a Gauss distribution. Now we have the average, mu, and we look at here at the distribution, not at the sample, and we know that between the average and one standard deviation, we have 34.1%, one standard deviation and two standard deviation, 13.6%, and 2 and 3 standard deviation, we have 2.1%. It's a symmetrical distribution, which means that we have 50% to the left and 50% to the right. So when I want to measure something and I say, okay, I have this distribution, I want to say, no, how many items, what's the percentage of the measures that are smaller than the average and one standard deviation is basically 50% plus 34.1%, which is 84.1%. Now, this is always the same, and when we want to do calculations, we also calculate a z-score. Basically, we want to use this in tables, and with tables, it will be very difficult to make a lot of tables for all values of the average. So basically what the people did is they reduced everything around 0. So x minus mu is in fact the distance between the value and the average. And when we are at 0, when x is equal to mu, z is equal to 0. And we divide by the standard deviation. So we find basically how many standard deviations is x to the left or to the right of the average. And that allows us to do a lot of calculations just with one table, and you've seen those tables. Now today we can use Excel and other programs. You just put the numbers in there and the program will calculate everything automatically. You can either use the Z value or you can use X with the respective parameters. Thanks to the computer, we don't always need those tables, but in many cases you will still have to use the tables or you want to know the Z value. Now when we look at uncertainties, we have what we call known unknowns. And known unknowns are things that can happen, but we know that something can happen. So for example, when you're flying with an airplane, we know that the engine can stop working. We know these things. So from the experience, we know that certain things can happen. Unknown unknowns are things that we don't know yet. So basically, when some event happens and we don't exactly know why, well, it's an unknown unknown, but from the moment that we identified it, it becomes a known unknown. And of course, we have act of God, eruption of a volcano, a tsunami, things like that, earthquakes. These are basically acts of God. Although we can find out ways how to predict, for example, eruptions of volcanoes. When you look at the people who are studying this, they see certain parameters, but it's still not 100% sure. The same thing with earthquakes. People can measure how is the pressure in the ground, and based on the pressure, they can say that the probability of an earthquake occurring increases, but you never know the exact moment. Now, when we look at some examples, you've seen them in the videos, the de Havilland Comet, people didn't really know about fatigue. The thing that happened in this airplane, they found those cracks due to fatigue and due to some way to construct. Just look at some houses. Sometimes if you see a window, always the cracks start in the corner because the tension is there the highest. We also have the Tacoma Narrow Suspension Bridge, which was called Galloping Gertie. Aeroelasticity created the problem, and basically we found out that the design had to be adjusted. So we learned from these things. Apollo 13, there was no plan. There was an explosion during the trip to the moon, and they had to find solutions on that moment. It was an unknown unknown. Also with Apollo 1, there were some things that they found out. They adjusted it and everything. The Challenger disaster, where one of the booster rockets, in fact, had a problem due to a rubber which was broken, and they learned that they should not launch the space shuttle when there were freezing temperatures out there. Ariane 5 first launch disaster. The Ariane 5 rocket is basically a rocket that was developed by the European Space Agency. One of my friends is a cosmonaut, and he was going through the training, so he knows also about all these risks and all the things. But with what happened with the Ariane 5 is that basically the navigation system was copied from the Ariane 4. And a copy-paste error is always very dangerous. What happened here is that the dynamics of the rockets that were programmed into the navigation system between Ariane 4 and 5 are basically different. And because of that, there was a problem during the first launch. Airplane cockpit procedures, we have seen the disaster in Tenerife, where the pilots were giving messages like cleared for takeoff, cleared for taxi, all these things. The clearance was misinterpreted by the crew of the KLM jumbo jet, and basically after this accident the procedures were changed. So when we see things, that when we have unknown unknowns or known unknowns, we try to find out what can we do about them. So we try to find solutions. Now when we work with risks, is typically the bad thing to do is to use the ostrich methods. People say the ostrich puts the head in the sand. When they see danger, they hope the danger is not there. Of course, the lion will not be out of there. Of course, people told me the ostrich is not really putting the head in the ground. It looks like that. But basically, the ostrich is looking away from the danger. Close your eyes, what kids do. Sometimes we say we close our eyes and we think the danger is gone. Now, this is not true. The good way to manage risks is to manage them and to be proactive. We try to find what's happening. We try to learn from the past. And of course, we have to apply the risk methods in proportion to the project. Implementing very expensive risk measures to resolve a risk which low cost or low probability may not be the way we want to do this. Now we have a lot of tools together. There are programs, we have Monte Carlo analysis and other tools that exist. Now, when we look at projects, we look at what we call the project management process. And the process has been changed, and you may have seen it in some other videos, so you have to be careful. We have risk planning. All processes start by by planning, and in this case, we have risk planning. The second thing is risk identification. We identify the risks. Then we have risk qualification. We try to have a subjective ordering of importance of the risks. Then we look at risk quantification. We selected a number of risks, and then we try to estimate how much the risk will cost when something happens. So basically, these are the things that we want to do here, and we have to take into account. It will also give us the financial basis for our contingencies. And here it changed a little bit. We first had only one step, implement risk responses, but now we have a previous step, which is plan the risk responses. So we're going to plan all these risk responses, and then we're going to implement them. And the last step is control the risks. We have to see how is our risk management plan working, and do we have to change something. Now it's very important to see how are these different processes of risk management related to the project management process steps. There is nothing in initiation, and we have in planning, we have 5 different steps. So we have plan risk management, identify risks, qualify risks, quantify risk, plan risk responses. Then we go to execution, where we are going to implement the risk responses, and in monitoring and controlling, we will be controlling the risks. When we look at the life cycle of the project, we have initiation, planning, execute, monitoring and controlling, and closeout. We can identify different levels of risks at each step. At the initiation and definition, we may lack information, there may be unclear objectives, there may be no subject matter experts available, and there may be a missing feasibility study. During planning, we may encounter an unclear statement of work, no management support, and limited team experience. During execute and monitoring and control, here we have most of the risks that will or that can happen. We may have strikes, we can have acts of God, we can have competition and changes that happen, we may have an inadequate control system, and of course events may occur during this step. During monitoring and control, we look at quality issues. People may be leaving the project. There may be problems with customer acceptance, and of course, cash flow. Now, the first thing we're going to look is at the plan risk management. And here we're creating the risk management plan. Now, we look at the risk strategy. What is the general approach to risk? We may have a general approach to risk for the company, how the company in general is dealing with risk, but in this case, we're going to look deeper into the way that it works for this project. Now, the methodology looks at approaches, tools, and data sources that we will use, roles and responsibilities, who is doing what on the project related to risk. When you have a very large project, you may have a project risk manager. When it's a smaller project, you probably be the project manager and the risk manager. We also have to look at funding. What do we have? We look at contingency and management reserves. Timing, what are the steps? How frequently are we going to repeat the risk cycle, the risk processes? We have different risk categories, which we will, let's say, put in what we call the risk breakdown structure. So we will have a look at that in one of the following slides. We look at the stakeholder risk appetite. So we have to see how much risk does a stakeholder wants to take. So we have to look at the risk levels that are acceptable for our projects. We also look at the risk probability and impacts, we have to define how these elements link together. What are the indications for probability? How do we evaluate that? And what are the measures we take or the relation we consider for the impact? And impact, we can have a look at the impact on time, cost, and quality. We have reporting formats. It's a series of documents that we're going to use. It's very important to have a set of documents because it will make it easier to comply with all the conditions, and it will be very easy for the management, for the leadership, for the sponsor, and for the stakeholders to identify what is really happening. People are used to those documents, and you can find the elements very quickly. We look also at tracking. We have documents that are used for tracking, and it's also a guideline for auditing. Now, the first thing I want to show here is the risk breakdown structure. You see all the different elements related to technical risks, to management risk, commercial risks, and external risks. You can make these for every project that you have. And of course, in your company, you may have a standard risk breakdown structure that you can start from. When you look at the probability and impact matrix, we look at the probability and impact scoring. So we look at how do we estimate those probabilities. And we say a very high probability, for example, is when the probability of occurrence is over 85%. And we have this for different elements, how we define this. So we have this scale. You can make this scale for you, let's say, for every project. We also have the impact on time, cost, and quality. So we see what does it mean? What is a very high impact? Well, it means that we have a delay from more than 6 weeks when the cost is more than $250,000. When we look at quality, that there is a very high impact on quality and functionality. And you can define all those for all the different levels that you want to use later in the probability and impact matrix. Of course, we also define the scoring scheme, and we have an impact matrix for threats and opportunities. Basically, they are the same, but the way we are going to react to them are a little bit different. I chose different colors also. And you see, when we have very high impact and probability, we have to quantify the risk. And we indicate the zones when we put the risks there in those different categories. When they are in the red zone, we have to quantify them. We have to make plans to deal with the risks. On the other hand, when it's white, the white zone means we're going to accept the risk. We just have to survive the project if this risk happens. If we cannot survive it, well, then we have a problem. So basically, we have those two zones, and in the middle, we have the risks that we have to monitor. We have to see what's happening. How is the risk evolving over time? So basically, the threats matrix tells us where are the threats that we have to make plans for. On the other side, we have the opportunities, and it's a little bit in the other direction. Basically, when we have a very high positive impact and probability, we see the dark green zone. So in that case, when our opportunities are in that zone, we have to take some measures to have the positive impact. We want to get those opportunities to be appearing, so we have to take measures for them. And the same thing, we have the elements where we accept the opportunities. We will not do anything to get them, let's say, let them happening. On the light green, we will monitor them. So we'll see what happens with those opportunities. Are they moving towards the left top? Then we may have to adjust our plan and try to take measures so that the opportunities will happen. If they move to the other side, well, we just see what happens and we don't do anything for that. So this was the first part of the risk management that I wanted to do. We looked at the plan, we looked at the cycle, we looked at the definition of risks. Let's now continue with the next part, and I'm looking forward to seeing you there. Thank you, and bye-bye.